Alright, so the first principle of the solid design principles that we're going to take a look at is called the single responsibility principle. And it's a very simple principle because it tells you that a class should have a single primary responsibility, and as a consequence, it should only have one reason to change, that reason being somehow related to its responsibility. In other words, it's a bad idea to add more than one responsibility to a class. So let's take a look at how this can actually work. Let's suppose you decide to make a class called journal, which you're going to use to store your most intimate thoughts. So in the constructor for the journal, what you might want to have is you might want to just initialize a bunch of entries, and these are the journal entries that we're going to populate. We're also going to count the number of entries. So here I'm just going to say journal.count equals 0, and we're going to increment this whenever we add the entry. So the primary responsibility of the journal is to add entries and remove entries. So first of all, I'll have the add entry method where you specify the text you want to add to the journal. We're going to prefix this text with an incremented journal count. So first of all, I'll say let's see equals ++ journal.count, so I get a 1, a 2, and so on for every single entry. Then I generate the entry itself, so let entry equals, and then just format the entry prefix by the count, so the entry and then the text here, and then I add it to the set of entries. So I say this dot entries at position journal.count, or in actual fact we can use the variable c because that's what we're using. So this dot entries at position c is equal to the entry, and then we return c. That's pretty much all there is to it. So that's how we actually assign the entry, and we can also remove entries as well, because at the end of it all you can see that we're returning the index of the entry, so the actual key of the entry. So you can have a method called remove entry at a particular index where you just delete this dot entries at a particular index. That's very simple. Let's also add a toString implementation so we can actually print the journal. So toString here is just going to take all the values of the journal object, the entries object rather, and turn them into a one big string line separated. So I'm going to return object.values from this dot entries, and I'm going to join them all together using \n. So that's pretty much it. We can now start using the journal. So I can make a new journal here. I can add a couple of entries. Add entry, I cried today. Let's add another one. Let's say I ate a bug, and we can actually print this. So I can say j.toString, and we can print this journal. Let's just run this. Let's see. So here is the output. I cried today, I ate a bug. You can see I'm prefixing it by the index of the entry starting at position 1. Okay, so coming back to the code, everything is fine so far because the journal is just handling its primary responsibility, which is the keeping of entries. It kind of makes sense that a journal is something that keeps entries. So you add entries, you maybe remove entries, and that's pretty much it. But imagine that you decide that you also want to be able to save the journal. Where do you put this functionality? Well, it might be really tempting for you to actually add this functionality right into the journal itself. So you might go ahead and let's just import the file system. So like so. So I'm going to import the file system, and then we're going to use it to save the journal. So let's suppose that right inside the journal you add a method for saving to a particular file name, and here you use the file system. Maybe you use write file sync to the file name, taking just the journal as a string representation. So this is something that it's going to work just fine, but the problem is that subsequently you want to have additional interaction with the file system. You might want to load from a file name. I'm not going to implement this, but later on you might also want to load from somewhere else. So let's say you want to load from URL, for example. Load from URL, or you specify the URL and you load it from the web. So the big problem with all of this is that you now added a second responsibility to the journal class. Why is this a problem? Why can't we have a second responsibility? Well, imagine you have some behaviors which are specific to serialization, specific to the saving and writing of data. Let's suppose that instead of doing toString, you want to remove those indices before you have the entry serialized. Let's imagine that, remember, up here I'm adding the index of the entry before the entry. Let's suppose you want to remove them whenever you save. And let's suppose you also want to have some processing when you load them. Maybe you save them with the indices, but you load them without the indices. So you have some common operations, which would be here and here, for example. Now, the problem with all of this is that imagine that a journal isn't the only object in your system. Imagine that you have 10 different types that you want to serialize to files and load from files and maybe load from some URI somewhere. How can you have common operations on all of these? And the answer is, well, it's going to be very difficult for you. So it might make sense to take all of these operations related to persistence, because that's what it is, persistence stuff. You might want to take all of them, remove them from this class, and just add them to a separate component that can subsequently be generalized for handling different types of objects, not just journal entries, but other things as well. So a good idea would be to take everything from here and just make a separate class, make a class that's called Persistence Manager. So you could have a class like this, which has a save to file functionality for which might take a journal, it might take a file name, and then it would do pretty much the same thing. So you would write file to a particular file name, just taking the journal to string, and you could modify it later on to sort of process the journal somehow in a method. Once again, you could have a method here for pre-processing the journal, which would do something, and you would apply this method uniformly across the entire persistence manager. Instead of having to hunt through lots and lots of classes modifying their serialization operations, you just keep everything local. So you keep everything right where you persistence functionality is. So it's better for organization and better for understanding what the code actually does and where the modifications need to happen. So you know that if your files aren't being saved correctly, you're not going to be looking in like 10 different places. You're just going to be looking inside the persistence manager. So here the idea would be as follows. So instead of just serializing, you'd make a new persistence manager, and then you'd specify the file name. And well, I'm on Windows, so let's do C temp journal.txt. And this is what you would use to actually save the journal to a file. So you just write something like this and run it. Obviously, we're not going to see any output here. Well, we are going to see some errors from, I guess, the imports aren't yet ready. So let's see. Const fs equals require. Let's do it like this. So this is going to be a lot simpler. So this is we're not showing anything extra because we're just serializing things. But the real takeaway here is what you see in the code. That it's better to group functionality by class instead of sticking all of the functionality into a single class, for example. In actual fact, there is an anti-pattern, and the anti-pattern is like a pattern that shows up which is bad as opposed to good. There's an anti-pattern called a God object. A God object is basically like this one huge massive class that has lots and lots and lots of responsibilities, lots of spaghetti code, very difficult to figure out. So the single responsibility principle is the exact opposite of that. It's the idea that you basically have to have just one responsibility, and if you need additional responsibilities, then just make other classes. They don't really cost you anything. Another term that we use quite often is called separation of concerns. So separation of concerns is what you do when you refactor, for example. So let's suppose you find a really complicated algorithm. What you try to do is you try to split it up into several different parts which are somehow related. So this idea of separation of concerns is once again this idea that if you have several different concerns like persistence, like I don't know, like some sort of post-processing, for example, like I don't know, parallelism, whatever it happens to be, then you separate those into separate components so as to make the entire system easier to figure out, easier to manage, easier to refactor as well.